So this section is all about the cardiovascular and respiratory systems, particularly the lungs. Lungs are very important in training, obviously. During this we'll look at a number of things. We'll look at the structure of the lung, the function of the lung, how the two relate. We'll look at the breathing muscles involved, which are important. They develop during training. We'll look at the passage of air through the respiratory tract and something called gas exchange in the lungs and the muscles. So this is important. Through the process of gas exchange is how your muscles get oxygen, how you're able to exercise. Further than that, we'll look at circulation. We'll look at the effects of exercise on cardiovascular and respiratory systems, and then the long-term effects of exercise on both the cardiovascular and the respiratory systems, and recognise how the cardiovascular and the respiratory systems change through a person's lifespan. So before we get cracking, as usual, just note down anything you know about the lungs. You can get a piece of paper out and just think. You might know some words for parts of the lungs or parts of the respiratory tract. You may know some stuff from school. Just pause this for a second and see what you can remember. And then see if it was any of this. So obviously you've got two lungs. You've got your left and your right lung, and they're located in the thoracic cavity. In the thoracic cavity, the thorax of your body, and encapsulated in the ribs. And you can see them here behind the ribs. And obviously the ribs are there to protect. So I don't know if you remember from the skeletal system, we said the sternum and the costal or the rib bones were both flat, and flat bones are often used for protection. And you can see the lungs are nicely tucked away in there to limit damage. There's still some design there. They can still expand and move a little bit, but they're largely protected. So the lungs then inhale to receive oxygen, and they therefore diffuse into the bloodstream through a process called gas exchange, which we'll come back to. And they'll also remove carbon dioxide from the body, again from this gas exchange process. So we bring oxygen in through the lungs, and we take carbon dioxide out through the lungs. The main breathing muscles we use are the diaphragm and the intercostal muscles. The diaphragm we can see pictured here, dome-shaped muscle that goes across the bottom of the thoracic cavity. When it's relaxed, it's in this position, and when it tightens, it pulls down into a straight line, pulling gas into the lungs. Your intercostal muscles sit in between the rib bones there, all right, and pull the ribs out and upwards to breathe in, and then back and down to breathe out. So you've got your diaphragm and you've got your intercostal muscles. Just a little experiment then. If you place your hands on your rib cage and breathe in a few times, you should feel, well, you tell me what happens, but you should feel the ribs expand in and out. And also worth just putting your hands on your belly and breathe in and out there. So if you feel your belly expanding and contracting, that means you're breathing through your diaphragm. And if you feel your ribs expanding and contracting, that means you're using more of your intercostal muscles. Obviously you use both in real life, and you don't often think about it that much. And the deeper you breathe, the more you're likely to use both systems of breathing to maximize your lung volume. So you can see here, during inspiration or breathing in, the diaphragm contracts, flattens down, and descends. What that means is pulling air into here through a process of vacuum. At the same time, you can see from these arrows, the lungs are expanding, or the rib cage is expanding. Both of those things are together are making the lung volume bigger. Once you've created a bigger lung volume, air is drawn in to meet that gap. When you breathe out, you can see the diaphragm relaxes now. That means it ascends, and you see the rib cage will fold back in. Both of those things will make the lungs smaller, pushing air out. So we've got inspiration and we've got expiration, we've got inhalation and exhalation, breathing in, breathing out, all the same thing. So let's learn about the respiratory tract. You can see it here in the way it's laid out here, so you can see how air would move in and out like a tide. So if we label some of these, you'll see nose comes in, the air comes in the nose and mouth, moves into the pharynx, which is the back of the throat, then the larynx, which is your voice box. If you put your hand on towards just under your chin as you're talking, you'll feel that vibrating. Then to your trachea, which is quite a solid tube running down the center of your chest. That will split then into two bronchi. So you've got a left bronchus and a right bronchus, two bronchi, and they will go into smaller branches called bronchioles, and then finally into air sacs called alveoli. Okay, you should be able to check that yourself. So, oops, go back. So when you're ready, you can go back one, and you can do that. Once you've had a look at that, make sure you can remember the passage of air. It does come a lot in exams. You can talk about gaseous exchange. So as air is passed down, it ends up through the pharynx, larynx, trachea, bronchi, bronchi, bronchioles and alveoli. And here is the air at the moment in here. You can see that there's lots of capillaries around these alveoli, and obviously this is where the gas exchange is going to happen. What happens now, so when the oxygen is here in the alveoli, it will then, you'll see in a minute, pass through into the capillaries. That will become then red, and they will return back through this tube to the heart. Similarly, the carbon dioxide will be brought from the heart, and that will pass from the capillaries into the alveoli, and then you get breathed out through the bronchioles, bronchi, trachea, pharynx, larynx, and nose and mouth. So I've put the link to this video in the links in your Google Classroom. Let's see, it will play now. So you can't play now, but I'll put the link in the Google Classroom and you can do that. And then looking at the effects of exercise in the respiratory systems. So immediately, as soon as you're out running or lifting weights or whatever you do, you'll find your heart rate going up. Your breathing will be faster. You'll increase your systolic pressure. So when your heart's beating, the pressure will be higher. You'll also vasodilate. All right, so we'll widen the blood vessels to the working muscles, and the increase of air in your lungs will increase. We'll increase the stroke volume. So this is how much the heart will beat each pump, which is quite good for making you fitter. And the amount of cardiac output, so the volume of blood pumped in a minute, will increase. So this obviously helps a lot during aerobic exercise. If you've got a high cardiac output, it means you're able to maintain a high speed or high rate of work. Long-term adaptations that will occur if you stress the cardiovascular system. We'll get a decreased resting and working heart rates. All right, so at any intensity, the heart will find it easier to work. So if you're sitting down, it will be fitter and it will pump less. And similarly, if you're running at the same speed, it will find it easier and it will work less. We'll get an increased aerobic capacity, and we'll get a normalized blood pressure. So if you had high blood pressure, it will start to decrease. You don't have to train very hard for this to happen. It's usually done by exercising at moderate intensities. We get increased left ventricle hypertrophy, so the muscle in the heart will become stronger. This is what enables you to have a decreased resting heart rate, because the heart is able to pump more in each pump. The size and the elasticity of the arteries increase. The elasticity particularly is good for maintaining your health. It stops them getting clogged up later in life. And you get an increased capillary network. This allows more gases to diffuse through the process of gas exchange and makes it more efficient. We get better strength in your respiratory muscles. Your diaphragm and your intercostals improve. We get stroke volume and cardiac output both increase because we've got a harder, stronger working heart. We've got reduced levels of bad cholesterol and increased levels of good cholesterol. We actually have more blood volume. This is one of the reasons why some people put on weight when they start exercising, but it's actually their blood volume that's increased. And we get more, the size and number of mitochondria increase, because remember we're using aerobic energy most likely, and therefore our aerobic energy factories will increase. If we just go through how things change over your lifestyle, so when you're born, your left and right ventricles are of equal weight because your body is quite small. But obviously as your body increases in size, your left ventricle will double that of the right ventricle. Resting heart breathing rate starts at 30 to 60 breaths, but we will increase the volume you breathe, and that also there the actual number of breaths will reduce, generally about 12 to 20 in an adult. By the age of 3, the lungs and the heart are a mini version of adult's heart, so they'll have the same kind of proportions, but then they'll increase. And the organs and the system stop growing around the same time as the person stops growing, so that's generally between 12 and 18. So one good way of remembering lots of this stuff is to write a little quiz. So if you write down some questions on any of those things, you can use a true or false type questions, multiple choice, short answer. You can have a diagram to label, you can have missing words out, and then try that on a partner. You do this online over the internet or through the Google Classroom, or you can meet face to face. So you should know the structure of the heart, the function of the heart. You should know the structure and the function of the blood and the blood vessels, and the structure and function of the lungs. It's always good to help your memory. Try and link the structure and the function of the heart and the lungs. Why is it that shape? Why is it that colour? What does it do? It's quite interesting. The main muscles involved in breathing, you should know these. You should know the passage of air. It's worth repeating that a few times. How gas exchange works in the lungs and the muscles. You should know about systemic and pulmonary circulation, the immediate effects of exercise on the cardiovascular and respiratory systems, and then what happens with the long-term effects if you train for a long time. And you should be able to recognise how the cardiovascular and the respiratory systems change in a lifespan. Ways of remembering more. Try the Kahoots on this topic, they're quite extensive. Test yourself regularly. Label pictures of the heart and lungs, it's worth doing. Ask each other questions. And just worth remembering at this point, sometimes there can be a lot of words that are unfamiliar, but embrace that. If you get something wrong, it just means it's closer to the next time you get it right. It's the challenge of learning that makes you stronger.